React.js is one of the most popular JavaScript libraries in the world. If you're interested in learning this language, please note that there are a few crucially important principles that you would need to know before you crash into learning React.js. In this video, we will try to encapsulate all these elements and explain how they relate to React.js. My name is Skutlo. Welcome to Coding 101. My job is to make your coding journey much more easier and much more simpler. Please make sure that you support our channel. Make sure that you subscribe to this channel. Make sure that you like this video. And if you want, you can leave a comment in the comment section. I'd be willing to answer any questions that you might have or any suggestions that you might have. I'd be willing to respond to that as well. So React is a declarative, efficient, and flexible JavaScript library for building reusable UI or user interface component. Now, the word that stands out from that statement is the word declarative. Now, declarative programming is a programming paradigm which is different from its counterpart, which is imperative programming. Declarative programming is a programming paradigm that describes what the program does without explicitly specifying its control flow. Imperative programming, on the other hand, is a paradigm that describes how the function should do something by explicitly specifying each instruction or step-by-step move which mutates the program state. Let's take an example of how these two programming paradigms are different. In this example, we have two functions that serve a similar objective of calculating the summation of numbers in an array, but as you can already see, the approach is quite different. The how approach, which is imperative programming, is much more detailed than its counterpart, which is declarative programming, which is a little bit more abstracted and is more results orientated. Now today, most of the websites are built using MVC, which is called the Model View Controller. M stands for model, V stands for view, and then C stands for controller. Now in the model view architecture, the V is responsible for defining the UI or the user interface. The controller contains the control logic, and the model contains or defines the data structure. Now, in our example here, we can see an example of how these three components interact with each other. Now, for example, let's say a user logs into Amazon and they want to buy something from Amazon, and they add, let's say maybe a drink, and they add a drink into their cart. What happens is that that input or that information is sent to the control logic. The control logic receives the update from the view, and then what it does is that it notifies the model to add the item in its data structure, and the model then finally adds that item in its data structure or its data model and updates the application to reflect the added item through the UI. So this is how these three components interact with each other. So in this entire architecture, the V describes React completely, or React is the V, which stands for the view. Now, a React.js application is made up of multiple components, and each component is responsible for outputting a small, reusable piece of HTML code. Now, the components are the heart of all React applications, and these components can be nested with other components in order to build one big chunk of an application, or to build an entire complex application. Now, in the example that I'm going to show you here, we have a to-do list application, and in order to build this to-do application, we have to split it up into different components. At the very top over here on the pink line, we have the pink border, we have the header of the to-do element, and then over here on the green border, we have the form whereby the user is supposed to put in their to-do title and then click that button over there in order to add that item to the data structure. And then over here in these individual yellow lines, in this orange border that you see over here, this orange rectangle, that is the to-do list. So that is a list of to-do items stacked up together to form a to-do list. And then within this to-do list, you have these 4 individual components that represents the to-do item. So all of these components that you're seeing here are stacked together or put together in order to create this whole to-do list application. And that is how you build a React application. In React, you break down a project into miniature components, and then you bunch those components up together to form an entire complex application, or to form an entire application. So React.js uses a virtual DOM mechanism to fill data in the HTML DOM. Now, before you continue learning about the DOM, please note that I have a DOM tutorial that you can listen to. If you don't mind, you can go watch that video and come back to this one. But it's okay, because I'm going to just give you a brief introduction into what the DOM is. A DOM is a tree-like representation of your HTML elements. So a DOM is an object which is created by the browser each time a web page is loaded. It dynamically adds or removes the data at the back end and when any modifications are done. Then each time a new DOM is created for the same page. So let's say you have a DOM over here. I'm going to just make a very rough representation of the DOM. So this is a simple collection of elements. So now every time you need to add a new element into your DOM, then this entire structure is going to have to be recreated afresh. This entire structure is going to have to be recreated afresh, because you have simply just added a miniature element into the DOM. So that means like everything now needs to be recreated. Now the advantage with React.js is that you don't have to keep recreating the browser DOM each time, because now you have something that is called the virtual DOM. Now this repeated creation of the DOM makes it unnecessary memory wastage and reduces the performance of the application. So this is why React took it into its own job to sort of like fix that situation. React still uses the same traditional data flow, but it's not directly operating on the browser's DOM immediately. Instead, it operates on a virtual DOM. So now React has its own virtual DOM, its own miniature virtual DOM that it deals with on the side, so that every time something is changed on that DOM, then React, instead of refreshing the real browser DOM, React would simply refresh or recreate this DOM over here. So it does not work directly on the browser DOM, but it has its own virtual DOM of which it runs on. But it does not run on it immediately, but ultimately everything that you're doing on the virtual DOM is going to be mapped onto the browser DOM. So now React uses the DOM just like any other web language out there, but React uses the DOM in a very, very special way. React uses a virtual DOM, which is a light version of the DOM. The only difference is the ability to write to the screen or write to the real DOM. In fact, a new virtual DOM is created after every re-render. So every time you re-render, the virtual DOM is created afresh. So the real DOM is not recreated afresh. The only time the real DOM is recreated afresh is if React notices a difference between the real DOM and the virtual DOM. So if React notices a difference between the virtual DOM and the browser DOM, React will only initiate or create or add changes to the browser that are not available or to the browser DOM, but are available on the virtual DOM. So if React notices that something is not in the browser DOM, but is in the virtual DOM, React takes that change, it computes the difference, and it takes that differentiation and it puts it in the browser DOM. Instead of having to recreate the browser DOM afresh, it only attaches the changes that have been made via the virtual DOM. So that is how React is different with HTML or vanilla JavaScript. It's different in that manner. Now, the other thing that we need to know about React is that React uses Babel.js, which is simply a transpiler, which transpiles new features into the old standard of JavaScript. So JavaScript is the language that the browser understands, of course, and we use different browsers to run our applications. Now, it does not mean that all these browsers understand all versions of JavaScript, because there are many different variations of JavaScript, from ES5 to ES6, ES7 to ES8. So this, unfortunately, doesn't mean that all browsers understand all these different variations of JavaScript. Some of these ECMAScript versions cannot be understood by most browsers. So what a transpiler simply does is that it takes in all the new features that have been created with the new versions of JavaScript, and it converts those new features into the old standard of JavaScript. So that's what a simple Babel.js transpiler does. Let me show you an example of how this works. Over here, we have an arrow function that is built with modern JavaScript. So what a transpiler like Babel.js simply does is it takes this arrow function and it converts it into the old function that we all know and love. So that is simply what a transpiler simply does. It takes the new version of JavaScript and just turns it into the old standard. So yeah, so these are some of the principles that you are going to need to know before you jump into React. If this video has been useful to you, please make sure that you subscribe to the channel. Make sure that you leave a comment in the comment section. Also make sure that you like this video, and I will see you next time in Coding 101.